Okay, let's just dive right in. Everyone thinks they know what traveling at light speed looks like. You know, from the movies. It's this one single image burned into all of our brains. Well, I'm gonna tell you right now, pretty much everything you think you know is completely wrong.
Whoa, hang on. What do you mean wrong? I know what it looks like. You hit the button, Chewie punches it, the stars go whoosh and stretch out into these long streaks, and you're flying through a tunnel of light. Come on, man, that's how it works. Everybody knows that.
Yeah, that's the myth. But the reality is so much stranger. Forget the tunnel of light. Instead, picture this. The entire universe, everything in front of you, just collapses into one single, blindingly bright, white-hot point of light. No way. Get out of here. So there's no star streaks, no tunnel, just a dot? That's it?
Yep, that's it. And, we're just getting started. That's just what your eyes would see. It's basically a bunch of bizarre optical illusions because you're going so incredibly fast. The actual physics of what's happening to space and time, that gets way weirder. So what's going on here is something called the aberration of light. And there's a really simple way to think about it. Imagine you're driving your car through a rainstorm, the rain's falling straight down, but from inside your car, it looks like it's hitting your windshield at an angle, right? Coming at you. While the faster you drive, the more it looks like the rain is coming straight at you from the front. Light does the exact same thing.
Okay, wait a second. So you're telling me that all the stars, the ones to my sides, even the ones kind of behind me, they all look like they're shifting and just cramming themselves into this one little spot right in front of me? That's exactly it. Your whole view of the universe just gets squeezed into this tiny little cone of light directly ahead. It would be totally disorienting. And it gets so much worse, because now we gotta talk about the Doppler effect. You know this from sound, right? Like when an ambulance siren goes, "Neo!" as it passes you, that change in pitch? Well, the exact same thing happens with light. And at near light speed, the effects are, let's just say they're extreme.
So all that light from the stars you're racing towards, it gets all bunched up. The light waves literally get compressed, which cranks up their frequency. It's called blue shift. So at first, all those stars would look blue, then violet. Then they'd shift right past what you can see into ultraviolet, and then into lethal high-energy X-rays and gamma rays. That bright dot in front of you isn't just a dot. It's a cosmic death ray pointed right at your face. And what about behind you? Well, it's the total opposite. The light waves from the stars you're leaving in the dust get stretched way out. The redshift, past red light into infrared, then microwaves, radio waves, until they're stretched so far they have pretty much zero energy. Your rearview mirror would just be pure, absolute black. Nothing. That's insane. So let me get this straight. You've got a death ray in front and a black void of nothing behind you. This is like the worst road trip ever.
Exactly. But look, everything we've talked about so far, that's just what you would see. It's all light playing tricks on you. Now, let's talk about what's actually happening to space and time. We're leaving illusions behind and jumping into Einstein's special relativity. And trust me, this is where things get truly mind-bending.
First up is something called time dilation, and the basic idea is just wild. The faster you move through space, the slower you move through time. That's it. Your speed in space literally affects your speed in time. And the effect isn't small, it's staggering. Okay, imagine this. You fly to a star that's 100 light years away. You're going at, say, 99.9% the speed of light. For you, on the ship, the whole trip might feel like it took, a few weeks. But when you turn around and come back to Earth, 200 years have passed. Everyone you ever knew has been dead for centuries. Wait, no. So a trip that felt like my summer vacation? I'd come home and my family, my friends, everyone just gone for hundreds of years? Man, I don't think I can even process that.
Yeah, you wouldn't be able to. And believe it or not, it gets weirder. Because here's the other side of that coin. It's called length contraction. It's not just time that warps. From your point of view, the universe itself literally shrinks in the direction you're going. All right, let's take a real-world example. Proxima Centauri, the closest star to us. It's about 4.2 light years away. For us, sitting here on Earth, that distance is, well, it's huge. It's fixed. But for you, the person on that ship blasting along at almost light speed, that 4.2 light-year gap might shrink down to just a few million miles. And the crazier part is, the faster you go, the shorter that distance gets. If you could get close enough to light speed, a trip that's thousands of light years long could feel instantaneous. Because from your perspective, the distance just disappears. It shrinks to almost nothing. Okay, this is blowing my mind. So, why are we messing around with 99.9%? Why not just crank it to 100? Just go at light speed? Yeah, that is the question, isn't it? Turns out the universe has a very hard, very firm speed limit. And there's a deep fundamental reason why nothing with mass can ever hit it. So what's the deal? I mean, a photon, a particle of light, does it with no problem. So why can't our spaceship, even the most advanced one we could possibly imagine, why can't it do the same? It all comes down to mass and energy. We've all heard of E equals mc squared, right? Well, it means mass and energy are basically the same thing. So as you push your ship faster and faster, you're pouring energy into it. But as you get really close to the speed of light, that energy starts turning into more mass. Your ship actually gets heavier. At 99.9% light speed, you're way more massive. To get to 100%, your mass would become infinite. And how much energy does it take to push an infinitely heavy object? An infinite amount. It's just impossible. And okay, here's the real kicker, the thing that just breaks your brain. From your point of view, inside the ship, you feel completely still. You feel motionless. And if you turn on your ship's headlights, that beam of light will still race away from you at the speed of light, no matter how fast you're going. You can keep pushing, keep accelerating, get infinitely close, but you can never, ever catch up. Wow. Okay, so that's it then? Interstellar travel is just a pipe dream? Are we just stuck here in our own solar system forever? Well, maybe not. See, the laws of physics say you can't travel through space faster than light. But what if you could move space itself? And that brings us to something called the Alcubierre drive, which is, for all intents and purposes, a warp drive. It's a really clever, theoretical loophole in general relativity. The idea is you don't try to fly through space. Instead, you create a little bubble of flat, normal space-time around your ship, and then you warp the space-time around the bubble. Okay, so here's the concept. You'd use some, futuristic tech to expand space-time behind you, literally stretching it out. And at the same time, you'd contract space-time in front of you, squeezing it together. Your ship just sits there in its little bubble, not moving at all, and it just surfs on this wave of space-time. And that wave could theoretically go faster than light. So, it's a cool idea that basically requires magic to work. Is that what you're saying? Yeah, that's pretty much it. To bend space-time like that, the math tells us we would need something with negative mass or negative energy. It's this theoretical, exotic stuff that, well, we have absolutely no proof it even exists. So, it's an amazing idea on paper, but for right now, it's pure sci-fi. So that's what it all comes down to, huh? Are we just stuck, or is there any chance we'll ever figure this out and get out there? That really is the ultimate question, isn't it? The physics we understand right now says the hurdles are gigantic, but, our understanding is always changing. What's impossible today might just be a problem that's waiting for a new kind of math. Who knows? For now, though, yeah, we'll have to keep exploring from afar. For more mind-bending space facts like this, you have to subscribe to Webb Watch right now. Yeah, you really do. Seriously, go do it. We'll see you next time.